I'm coming to you not as a fellow master naturalist as much as I'm coming to you as a representative of the USA National Phenology Network, which is hosted by the University of Arizona in Tucson. They receive funding for a project called Time to Restore, and I'm going to be talking a little bit about that project tonight. The intent of the project is to engage volunteers in a community science effort to help us collect information about native plants and the pollinators that rely on them to better inform pollinator restoration projects across the 4-state region of Texas, Louisiana, New Mexico, and Oklahoma, which we call the South Central part of the US. This project has been underway for about 2 years now. Texas recently joined the effort. We're going to be talking a little bit about that, okay? So here's an agenda that I'm hoping to address tonight. I'm going to give you a little bit of background on the Time to Restore project, what it is. You may have already heard several weeks ago, I actually did a talk for the Elm Fort chapter, which is over in Denton County. And so the word has started to get out. I also did one early January for the Cross Timbers chapter, which I guess is Tarrant County and the western part of the Metroplex. So we're slowly making our way across the state. Up to this point, I've done about 7 or 8 of these, and we're have another 7 or so still to go, and more being scheduled as we go. So we'll talk a little bit about the background of the Time to Restore project. We'll also be talking a bit about priority nectar species for Texas. I mentioned this is a 4-state effort. Texas has its own unique species that we are tracking for this project because of the size of the state and the number of ecoregions, as well as the diversity of the plants and the pollinators that interact with them. I'll be talking a little bit about the tools we use in Time to Restore, as well as the basics of data collection under this project. So I'm going to apologize on the front end here because I'm going to be going really fast. The presentation you're receiving tonight is actually my best attempt to condense a 3-hour workshop down into about an hour. So I'm going to be going really fast. Please, if you have any questions, post them in the chat or hold them till the end. I will stay on this call and make sure your questions get answered, I promise. But in the interest of kind of getting through this hour of information, please hold those questions and we'll get to them at the very end. Towards the end, I'll talk a little bit about informational resources available to people who are participating in the project. And then finally, we'll talk a little bit about next steps or where we go from here. So it's an ambitious agenda, but I'm going to jump in and see if we can get going so that you can learn a little bit more about this exciting project. As master naturalists, y'all do not have to be told about how diverse our state is. I mentioned that this is part of a 4-state project. Louisiana, Oklahoma, and New Mexico actually led in the project. Largely because they were much smaller and it was easier to bring them online. Texas was delayed because there was a real concern that with such a large state with a lot of ecological diversity, they didn't exactly know how best to move forward with bringing everybody online. Long story short, back in the summer, I came on board and we've been working to do outreach and get a rollout plan for the project here with a lot of success and a lot of enthusiasm on the part of particularly master naturalist chapters as well as NIPSOT chapters across the state. And so that's part of why I'm here talking to y'all tonight, and part of why you'll continue to hear about the project, particularly over the next couple of years as we really gain steam and collect data for this effort, okay? I will go ahead and disclose to you that the project, because Texas is so large, the project is really focused on the eastern, half of the state. So if you drew a line on this map from Wichita Falls to Laredo, you're going to notice that a lot of the plant species, as well as a lot of the outreach efforts, are focused really on those large urban centers around North Texas, down I-35 to San Antonio, and then over to Houston, and the ecoregions those areas are in. That is just because of the limited amount of resources we had for the project. It's not meant that any part of the state can't participate. It just means our efforts are really kind of focused on the eastern, 2/3 of the state, because of the limited amount of resources that we have for the project. Okay. Also, probably don't have to tell y'all that change is coming. Anybody that's been in Texas longer than I have, and I've now been here well over 3 decades, knows that we've seen some weather changes, right? We've seen more and more warm extremes, more and more warmer winters, fewer days with rain, but when the rain does come, it tends to be in a heavier rain event. We can expect that to continue into the future. Meteorologists and climate researchers tell us that the trend of a warming climate is reality for us. I'm telling you all this. It was just a few weeks ago, I had 4 inches of snow on my porch here in Houston, which I wouldn't have believed was likely to happen. But it did. And so the extremes of what's happening in our weather patterns is noticeable. It is impacting us as humans. It's impacting us in terms of our economic cycles, but it's also having a major impact on the ecological environment. And this project is really an attempt to try to start to gather data to better understand what's happening as our climate evolves and changes. Okay. We know already, last point there, that we're starting to see earlier first leaf and first bloom in plants across the state, particularly as warming cycles are longer and longer here in Texas. We're also seeing fewer false springs across most of the state, and we even had one here recently. Just a few days ago, we had a 3-day freeze here in the Houston metro area. That put a lot of plants that had already started to set bud and begin to bloom back a few days. So climate is changing, and this project is meant to hopefully better understand that. As climate changes, there are a number of ways that we try to understand that, and a big one is phenology. So phenology is purely the timing of plant and animal seasonal events and their relationship with climate change and other abiotic variables. So you're going to hear a lot about phenological change, phenological phenomena in this presentation. All of that's meant to say is it's just seasonal events. So deers in rut, wildflowers blooming, birds building nests, those are all phenology phenomena that can be recorded and observed. And this project is at the thrust of that particular effort as we try to gather data to better understand what's happening as our climate evolves. Okay. This slide will show you that there are a number of variables that drive flowering date for plants. And because this project is largely focused on native plants, you're going to see me kind of move in the phenological understanding of phenomena that really centers on plants, native plants, and how they experience that climate phenomena across our state. The variables are many. The ones I would draw your attention to probably more often than not are warmth and day length, because those are the ones that seem to be really having an impact on native plants that we can already see happening. Okay. Here's a case in point. Here is a slide that was put together. This was a study that was commissioned by the United Nations Environmental Program in 2022. And what they did was they conducted a study looking at groups of organisms across the globe and what we could already see as the planet continues to warm. The two noticeable groups of organisms that really show up on this graphic are plants and birds. So you can generally interpret this graphic to show that the darker the sphere, the greater the preponderance of the variable and the data that was collected to support it. So the two takeaways here is plants are beginning to flower and produce leaves earlier, about 5 days earlier than they previously did. And birds are starting to hatch their young earlier, about half as much in about 2 to 3 day phenomena. And then breeding and egg laying is also occurring. The interesting thing is that some of the other organisms that we already know are heavily reliant on plants and impacted by birds do not appear to be either displaying what's happening with them in the data that was collected for this study, or may not even be impacted. And so we were starting to think and starting to understand that there's a mismatch. And this study, this project, is actually meant to try to help us understand kind of what that mismatch might be as it displays itself here in Texas and in the 4 states of the study. Okay. Here's an example, a graphic that shows a project that's already come out of a related tool that I'll be sharing with you later in this presentation, which is called Nature's Notebook. It's the tool we use to gather the data. But you can see that for the common milkweed species, which is a species of importance to us in this project, you can already see that the species is starting to bloom earlier, about 7 days earlier, actually, in the Northeast. And that's shifting with climate. So as climate warms, the plants have started blooming about 7 days earlier than they normally would. The interesting part, though, is that right now we haven't seen initial growth or seed ripening changing. So that's part of that mismatch that we don't yet understand from a scientific perspective that we hope to better understand through this project. Okay. Here, just like we talked about the setting of flowers and how that impacts plants, seasonal events also drive pollinators and how they show up with presence. So this project is really meant to understand, the relationship between native plants and their pollinators as climate change evolves. In the face of climate change is how we typically phrase it. Once again, you see a lot of overlap here in terms of the variables that drive pollinator presence. Warmth is here, rainfall is here. But that really doesn't surprise us as master naturalists because of the fact that we automatically know that we're all kind of related in a bigger cyclical manner. And so things that impact pollinators, impact plants, impact humans, impact many other ecological organisms that we share our environment with. And so we just want to kind of emphasize here that this relationship and how pollinators and native plants interact is really important in terms of what this project's about and what we hope to learn through doing it. Okay. I mentioned that we know that there's a mismatch out there. The most typical pattern identified thus far is that plants are blooming earlier, and we believe that the insects may be trying to respond to that, but we don't have the data to really help us understand that as of yet. We also there are some exceptions with consequences for plants. For instance, if the flower is blooming earlier and the insect's there to take advantage of it, we know that's good for the flower or the plant, but we don't know what that means for the insect or the pollinator that came to pollinate it. And so as we start to understand this project and collect data to support it, we hope to better understand that mismatch, okay? There are a ton of questions that are important and really of concern to any number of entities, individuals, and governmental entities that are involved in pollinator restoration that they would like to have answered. And we can't propose with this project to answer all of them, but I would draw your attention to the question there, probably on the right part of your screen that says which species are becoming mismatched. We do hope that this project will help us understand that question a lot better. And as we get into the details of the project, you'll start to see how that kind of has been framed up as an overall effort here. But there's many other questions that are also out there. Where to plant, when to collect seed, what to plant, are all meant to be questions that drive better decisions about pollinator restoration. Okay. I mentioned that we're trying to understand the mismatch. We already know a lot about what plants, particularly native plants, offer to the pollinators that visit them. This graphic shows you bats, bees, and beetles are large groups of organisms that are heavily involved in the pollination process. We know a lot about the color, the nectar, and what these individual groups are motivated by. What are they looking for when they engage in the pollinator process? And so we know a lot about what they're looking for. What's missing is we don't know when and what happens if that when question gets mismatched. If the pollinator is looking for a plant that has not yet bloomed or has already bloomed, what does that mean for both of them? Does that mean a plant doesn't get pollinated? Or does that mean something else is stepping in to address that niche? And then what happens to the pollinator if it's unable to gather that pollen or those resources to further its life cycle? Those are the kinds of questions we're grappling with. And the bottom line is we just need more data. And that's what brought this project forward. And that's where I'm going to kind of go next in this presentation. Okay. So a little bit about the team. I mentioned that this is a 4-state effort. So Louisiana, Oklahoma, New Mexico, and now Texas. Louisiana, Oklahoma, and New Mexico actually started about 18 months ago. So they've been well underway with the project. And that was a largely driven by the fact that they were much smaller. And so the rollout of the project in terms of outreach was much more manageable. Texas did not actually come to this project until last summer. And many of you may have actually participated in workshops that we did to assess and determine which species we should focus on back in August. We did 2 virtual workshops back in August that produced a list of plants that I'm going to be sharing with you here in a minute that let us focus our efforts under this project to really study and gather data on. Okay. At the bottom of this graphic, it also shows you the partners that are parts of this part of this project in the various state components. I actually am affiliated with the University of Arizona and the USA NPM, or National Phenology Network, but there are a number of other organizations that are involved in the other states. For instance, the UT Butterfly Farm is heavily involved in Oklahoma. The Tribal Alliance for Pollinators, heavily involved in Oklahoma as well. The Bosque Ecosystem Monitoring Program is heavily involved in the New Mexico effort. And the Gulf Coast Phenology Trail is heavily involved in the Louisiana effort. So we're all kind of working towards a common goal in this project, so that the larger overarching goals for us are shared. But there are some specifics that you're about to learn about that are specific to Texas, and I hope you'll see why they're specific and why we had to go there, okay? Lots of questions we hope to address with the project, but the biggest one that I want to point out and direct your attention to is that third one down at the bottom, and that's about how will bloom and seed periods shift in the face of climate change. That's at the crux of what this project is about. And so as you consider becoming a part of this project and becoming a data collector in this effort, the big question for you is the data you will be collecting will largely go into us trying to understand that change. What is happening as the climate changes, bloom and seed periods are shifting, and the data you will be collecting will actually help us better assess and hopefully address that question, okay? That brings us to the time to restore in Texas. I mentioned the other 3 states had gone ahead. We now, back in August, kicked off the Texas effort. I mentioned that we had a workshop in August. It included about 500, I think, individuals, organizations, state representatives, many master naturalists, many NPSOC members that are heavily involved in any number of activities that are concerned with native plants and the pollinators that visit those native plants. And so the outcome of that workshop was to try to get to a species list that we could target for the Texas effort. And through many efforts from many individuals, we were able to do that. And we now have a list of almost 30 plant species that are the focus of this project. And we're now rolling out the data collection effort, which this is part of, to seek master naturalists, NPSOT members, and other interested volunteers in collecting data under the effort on these 29 species. Okay. I would point out that the goal here is that as you collect data, it will feed into a model that will produce a number of variables that will then go on to further inform pollinator restoration efforts, not only in Texas, but in New Mexico, Louisiana, and Oklahoma. So the effort here is that it's a cyclical feeding of data into a model, and the outputs would be ongoing as the project progresses. And that's the goal of our effort. So please understand that while you're collecting data at your site, it's going into a much larger effort across the 4 states to help better inform pollinators in terms of what's happening with the climate, and what's happening with the plants in the face of the climate, and how can we be better prepared as the climate continues to evolve and change. Okay. I mentioned that the 3 other states had gone ahead. I'll point out that these are the 8 species that they all study. These are their target species. So you'll probably recognize some of them, but most of them you may not recognize are particularly common or plentiful in Texas. And that was a great concern when I came into the project. In fact, one of my first recommendations was the diversity of Texas, the size of Texas, and the population centers of Texas really would struggle with this list to try to have opportunities to be able to collect the data we needed for the project. I mean, common sunflower, that's fairly easily found across the state. If you're in a wetter part of the state, buttonbush is easily found. If you're near large parts of the state that have still prairie remnants and other types of wildscapes that use coneflower, you might be able to find it. But many of the other species here are really difficult for us to be able to incorporate into our pollination project efforts, and are also somewhat difficult to find in the wild. And so the first conversation we had was we really need a more comprehensive list that worked in a much wider part of Texas. And so that's what that workshop was all about. We took these 8 and we said, we will add them, we will start with them, but we want to go to a new list that better serves Texas. And so that's what the workshop did. It went through a number of exercises to take plant species that we had been using in wildscaping projects and native gardening projects. We took the native plant NPSOT list. Many of you may be aware, NPSOT maintains plant lists for all of the ecoregions of the state. And we took those plant lists and used those to start to synthesize and bring commonality to plant species that were both common in wildscapes and native gardens, but also very common in the wild. And so when I reveal the 29 species that are now on our target species list, you're going to start to see where those efforts were kind of intersecting and why they became very interesting and important to us. Once I had the NPSOT plant list, I then went in and said, okay, which are the plant species that are both widely distributed but also commercially available, so that if somebody wanted to participate in this project by planting a wildscape in their yard, what species would they most likely probably use in those wildscapes, so that we had plants that were easily identifiable, easily accessible for people much like yourself that are volunteers that are interested in helping out the project. I then cross-referenced that shorter list with the LBJ Wildflower Center's database to determine where the distribution of the plant was and the bloom time for that species, because we were looking for the widest distributions for both. And then finally, what I did was I took the Xerces Society and tried to understand, of the shorter list that we had, which of those species really focused in on helping pollinators. They were either great nectar sources or they were great other benefits to pollinator species, and tried to identify those and sync them up in a matrix. All that said, we took the 8 species, we added a much larger grouping, in fact, another 21 species, to get us to a final list of 29 species for Texas. This graphic shows you that list, and I'll be happy to share this with Vicki and she can share it with all of you, or you can actually go to the Time to Restore website and download a copy of this for your own use. It's available and very easily accessible. But let me explain to you what you're kind of looking at, because it is at the crux of kind of what the project's about as it's been rolled out in Texas. Okay, so at the very far left-hand side of your screen, you will see there are 8 orange species. Those are the 8 we carried over from the other 3 states. Okay, we then added the other 21, which are the species that show up in black. Now you should start to see species that you readily recognize as a master naturalist or a NPSOT member, as plant species that you have some familiarity with. You either have them in your own personal wildscape, or you are a volunteer for a native garden somewhere, or a demonstration garden, or you visit a natural area somewhere near your home and you see this species. And that was the intent of what we were trying to do with this grouping of 29 plant species. The next column shows you the Latin name. The column after that shows you the distribution. Now, I mentioned that we are trying to stay true to the 4 states that were a part of this project. So there are no plants on this list that would only be found in one state. In fact, to make it on this list, you had to be found in at least 2 states. So you'll see down there's some Oklahoma, Texas, some Louisiana, Texas, but we really tried to get to 3. So if we could get to Louisiana, Oklahoma, and Texas, that was really exciting for us. And then, of course, if we could find a plant species that showed up in all 4 states, that was even better. So that's what the L, the NM, the O, and the T stand for. It's the first letter of the state in which the distribution of that plant species is found. Okay. The next column is actually the bloom months. I mentioned that we're trying to understand the timing of when plants are blooming and when they are setting seed, and to better understand how that's changing as the climate warms. And so we purposefully have selected plants that have very long bloom cycles. So that's what the red represents on here. So that's the first letter of the month. And in red shows the month that it's known to be in bloom in some part of Texas. Now, obviously, in the southern part of the state, that bloom cycle is probably longer. In the northern, it may be shorter, but generally these hold true across most of Texas, particularly the eastern 2/3 of the state. The next column shows whether the species is noted to be a particular nectar source for pollinators that actively interact with that plant. So if a Y shows up in this column, it identifies that this plant species is a particular note by the Xerces Society as beneficial nectar source. The next column, the SVTMB, is actually stands for special value to native bees, is what those first letters represent. And this shows you the group of, many of y'all will know that the bees are one of the largest, native bees especially, are one of the largest groups of pollinators across the continent here in North America. And so we tried to hone in on plant species that were known to be really to bees, especially native bees. So in this column, if an NB is present, that means this plant species is known to be very important to native bees. If it also includes a BB, it means that that plant species is also important to bumblebees. And then finally, if it includes an HB, it's known to be very important to also honeybees. Yes, we recognize that honeybees are not native to North America, but they have become very important in the pollinator equation. And so we have identified them on this list if that plant is known to be a frequent host of honeybees. And so you can see that there's a very great preponderance of plant species that are regularly known to be interacted with by bees, bumblebees, or honeybees. Okay. The next column actually identifies that there are a couple of these plants that are known to provide something other than nectar to the pollinators that regularly rely on them. One is the eastern redbud. I think the other is the Texas thistle. If we have time later on, I can get into kind of what those plants also provide. But I went ahead and noted that because it is interesting that those two plant species not only provide nectar, but they also provide something else to pollinators and the organisms that interact with them. The next column, and this was kind of interesting, it actually is SCBC, which stands for Supports Conservation Biological Control. And this is a variable that's tracked by the Xerces Society. And more often than not, this is a plant, a native plant, that actually regularly plays an important role with a species other than a pollinator that's important for a biological control of pests on that plant. And the reason why this is important is we believe that there's an interaction or an important relationship between pollinators and these organisms. I'll go ahead and tell you that most of these organisms that fall into this column are wasps, native wasps, because they regularly visit these particular plants and interact with the pests that are found on these plants. So they're a benefit to the plant itself in its cycle in terms of reproduction and furthering its life cycle. NN, the next to the last column, that's just meant to signify whether the plant is currently or already in Nature's Notebook, which is the tool that we use, and I'll be talking about that in a minute. These plant species are already in Nature's Notebook. I'm going to go ahead and tell you now, there are 8 species that are not right now, that they are currently working on getting added in. And so we've had a couple of months that they've been working to get them into the tool. And so just please be patient there as we kind of move forward with that, because we're trying to get all 29 of these species into Nature's Notebook so that when you do data collection, you're able to do that from your phone, and it's a very easy and seamless process. And then finally, the last column on this list actually shows you alternate names. Everybody here probably knows that common names can be a real downfall when it comes to particularly plant species. And so we've added a column on here that shows an alternate name that can be found in many databases, but that ties back to the plant species that most Texans know, which is the very first column here. Okay. So that's the actual 29 species that we were able to produce at the end of August last year. This is the target priority plant species list for Texas. It's our official list. And the really exciting part about this is you don't have to have any more than one of these plant species to participate in this project. So do not feel like you have to have one, all of them, or half of them, or even a third of them. You can participate in this project if you just have access to one of them. And that can be one of them in your flower bed, or that can be one of them down the street in your favorite nature area, or a local wildscape or a demonstration garden. So if you know one of these plant species, it's important and special to you, you could be part of this project. And so with that, I'll kind of jump into kind of talking about collecting data for the project, because that's the second part of this. And I mentioned that this is originally a 3-hour workshop. This is the part that normally we spend about an hour and a half going through just on its own. So what we've gotten to up to this point was actually what was the first hour and a half. So I apologize again for going very fast. But now we're going to transition over and talk a little bit about kind of how you go about collecting data for the project. Okay, but before I do that, let's talk a little bit about kind of how and the general parameters of this project and kind of how it rolls out. Okay, I mentioned that you can participate in the project with as few as one of those plant species. You can also participate in this project if you only have one plant of that species, or you can do a patch of that plant. So many of y'all know Turk's Cap. I know I, for many years, worked on a wildscape that our chapter managed and took care of at Fair Park and in downtown Dallas. Turk's Cap is one of those species that's really difficult to observe from a individual plant species, but it's real easy to do as a patch of Turk's Cap. And so that gives you an example of kind of how you might approach this if you wanted to be part of the project. You know, so you can look at an individual plant, or you can look at a patch of plants in this effort. If the data collection effort is very forgiving, and the plants are meant to be kind of dynamic as you observe them and interact with them as part of this project. Okay. The other really exciting thing about this project is that you can do it either alone. So you can literally do this project in your front yard, in your flower bed, as long as you have one of those plant species in that flower bed. But you can also do it as part of a group. So many organizations, you know, like the nature preserves or botanic gardens or any number of those, you know, the Herd Museum, for instance, could very easily host a group that does set up a collection effort under Time to Restore for a demonstration garden they have there. And one or more of the individuals could either collect the data together or take turns going and collecting data for that same site. So it's an exciting way to do something together. If you ever did Amphibian Watch or Stream Team or any number of the other community science projects that Master Naturalists often get involved in, this can very much be in that same vein. You can do it as a group. You can learn from each other in terms of what you're seeing and observing, and it can be really exciting. Okay. I also mentioned, and I want to reemphasize with you, you can do this in your own yard. So you can do it in your flower bed, like is illustrated in this photo, or you can do it in a butterfly garden nearby, or at a nature preserve or a wild area. All you need to have to be able to participate is access to one of those 29 species of plants on a regular basis, and then you can participate in this project. Okay. So that's kind of the nuts and bolts of kind of how you get to become interested in this effort and how you might be able to become a data collector under it. I also will share with you there are two ways to do that. There is iNaturalist, which many master naturalists and other volunteers use to collect data for the effort. And I'll talk to you a little bit about that. But I'm going to spend more time tonight talking about Nature's Notebook, because that's really the tool that we created to help us collect data on an ongoing basis. Because what you're going to find is when I talk about iNaturalist, it's really a one-time visit, and it doesn't give us the ability to understand the overall timing of what's happening with that particular plant that you're observing. Nature's Notebook will let you do that, okay? But first, let me talk a little bit about iNaturalist and how you do that. If you wanted, you know, if you said, I just don't have a lot of time to add another app to my phone or computer, I already use iNaturalist. I want to use iNaturalist. You can do that with this project. You just literally, you go to your iNaturalist, you bring up the app on your phone, you go in and you do a search for the Time to Restore project, and it will come up, and you just join that project. And that's a very easy process. I don't know how many of you may have done it. If you have any problems, I'm happy to help you with it. But it's a fairly easy process. You can search Time to Restore project, and it will come up, and you will select it. Then you'll just go about your regular iNaturalist process, and you'll photograph and upload your plant or that you observe, and it will be captured by the project automatically. I do add the one caveat is that to make it useful for time to restore, you do need to take a picture of at least a flower or fruit, or it really won't provide useful information to the effort. Because keep in mind, the timing is not here. It's really by you taking the photo, that's when you're capturing that it's in flower or it's in fruit, which is really important to our overall effort. If you use iNaturalist, you don't need to establish a site. You don't need to categorize your observation, even though I will tell you, iNaturalist just recently added phenological data to their observations. So there is, under each of the plants that you would potentially photograph and add to your iNaturalist, you have the ability to identify whether a plant was in flower or whether it had fruit on it, but you don't have to do that. And then finally, which is usually one of the more exciting things for people who are using iNaturalist here, is you never have to return to that plant. We will capture that data in the background as long as it's one of the 29 species that we identified as target species for Texas. So that's how you could participate under iNaturalist in this project. I will tell you that originally iNaturalist was not an option. We have now added it as part of this project because there are so many iNaturalist users. And so we felt like to not try to gather that data as we were moving forward with the other part of this project was a bit of a loss for the effort. And so that's why we've got back in and created this iNaturalist avenue. The better way to assist with this project is actually Nature's Notebook, which is a free app. It's available for both Android or Mac, or iPhone, I mean. You can go in, it's in both of the app stores. You can download it, it's free. Just like iNaturalist, it works very similar. In fact, that on the right-hand side of that image there, you will see that's exactly what the screen looks like when you go to your Nature's Notebook app. And the beauty of the app is that it lets you answer a series of yes/no questions when you're doing your data collection on one of those 29 species. So it's a very easy process for you to go through and do. And I also do a little plug for my colleagues at the University of Arizona. The QR code on this graphic, if anybody has an interest and wants to take a picture of it, will allow you to go in and participate or be part of a pool that is now being assembled as we redesign Nature's Notebook. So we're going through a process with Nature's Notebook for a 2.0 version, which will make it much more dynamic for the users. And if you take a picture of that graphic, you can be added to a pool that will be part of the test population that will be invited to provide comments and experience expertise as the 2.0 version is redeveloped and refined over the next 2 years. So if you have an interest in doing that, please feel free to join in. Once you've downloaded the app, the next big thing you do in your app is you have to select your site. And for many, this is as easy as putting in the address of your site. But if you don't have an address, for instance, if you're working in a nature area, you can easily use your phone to determine the GPS coordinates for your site. I will tell you that it's really important that your site be convenient. So don't pick a site that you don't get to visit very often. Don't pick a site that's not very representative of the area that you generally live in or frequent often. You also want it to be relatively uniform and in of an appropriate size. The size comment was put in there because really our standard really says you shouldn't have a site more than 15 acres. But I'll tell you, the sites I use, and I have 7 of them that I manage under Nature's Notebook and Time to Restore, All of them are literally, my sites are drawn right around the plants I observe. So they're as small as, a 10 by 10 patch, because I don't really select sites that are more difficult for me to observe or visit. And that's perfectly fine. There is no benefit from having a massive site unless you're going to be visiting a lot of plants in that site. And you're going to see as we get into a little bit more of this, it's really important that you not make this overwhelming from the beginning. So I shared with you that there was the 29 species of plants, but don't let that overwhelm you. You really want to select a couple of species and focus in on them as you begin your efforts under this project. I will go ahead and plug this. And Vicki started off when we first talked, or she opened up the presentation for me. We will be doing at the Elm Fork the Elm Fork chapter had made a request for us to focus in on selecting a site. And so Thursday night, 2 nights from tonight, we will be doing at 6:30 a focused training on how to set up a site. In fact, we will be doing it from a computer screen and you can access it virtually. So if setting up a site is something you have an interest already in doing, you can join that. And I'm going to give you here in a minute a QR code that will let you register for that training. And even if you can't make the training on Thursday night, please register for it because we will send everybody that registers for it a link to be able to watch the recording after the fact. And so if you think this project's something you might be interested in doing, please take advantage of that, building a site. This does seem to be the part that most people are somewhat nervous about. And the training on Thursday is meant to kind of walk you through that whole process, which is a very easy process. If you've ever interacted with iNaturalist, you'll very easily see kind of what we're doing by setting up your site. Remember, setting up a site is important because you're going to be revisiting that site on a regular basis to collect the data on the plants you have specified in your site. Okay. With that, let me jump into selecting the plants. Once you've set up your site, you will then need to identify in Nature's Notebook which plants you are going to be observing, okay? And that can be, as we mentioned before, that can be a couple of single plants, or that can even be a patch of plants. There's no magic there. Pick the ones that you will be most comfortable with, and then focus in on them. I believe this graphic shows you 2 poppy plant or 2 penstemons and a patch of poppies. But you probably can tell this was a California example that this was used for. Poppies are not very common here. But anyway, you get the point. And so once you've selected those plants, once you input them into your site, the app will go ahead and number them for you. So, for instance, you'll go in, you'll say, I want to track Turk's cap. I want to observe my Turk's cap that's in my flower bed in front of my house. So you go in, you put in your address. Then that address will make that your site. You then answer a couple of questions about how big is your site? Is it something you water? Is it something you've planted? So it gives us a little bit of indication as to whether this is a wild occurring plant that's wholly reliant on rainfall, or if it's something that you have planted as part of your wildscape effort, so that we understand the context. And then you will then do a search for Turk's cap in the database. So it will say, it's time to add your plants into your site. You will then select Turk's cap and you will identify that as your first plant. If you only select one Turk's cap, it will just say Turk's cap. But if you elect to observe 2 different Turk's caps, say in 2 different parts of your wildscape, you could do that and it will individually number them. So one will become Turk's cap 1, the other one will be Turk's cap 2, and so on and so forth. Okay. Patches work the same way. If you have 2 patches of the same species, they will be given separate numbers so that you can follow them in your site. I strongly encourage people when you're first starting out to not select more than three plant species to track or observe as part of your effort under this project. And the reason why I say that is because it can become very overwhelming if you try to put in all the plant species in your wildscape, because many of them on that list of 29 are absolutely data observable. Okay, so but just focus in on a couple, three max that you really like, that maybe even do really well in your yard, and you know there will be a great relationship between you and your observation efforts, and go ahead and add them in as part of your site. Okay. Once you've got that done, you've now selected your plants as part of your site. Remember, this project is really going to have you observe phenological phenomenon for the plant species. But the beauty of Nature's Notebook is you can also add other organisms. And I'm trying not to overwhelm you with this, but you can add other types of organisms to your site. For instance, and I'll just share this with you, of the 7 sites I manage, I have a standing list of 12 other organisms I add to every site. 3 of those organisms are birds, 3 of them are butterflies, 3 of them are other insects, and 3 of them are mammals. And I just add them to every site because I kind of, as a master naturalist, believe in this kind of complex web that's focused on that site. And so that gives me the opportunity to record data for them. It won't support what we're doing with time to restore, but at some point in the future, your data could be used for some other study that was, for instance, one of my mammal species is the fox squirrel. There may be some study in the future that wants to know, how prevalent this species was in pollinator, my personal pollinator garden, and they would be able to capture that data and know exactly when that organism was prevalent in my site. Okay, so that's something you might do. I also usually bring that up for people who are trying, if for instance, if you're an insect person and you're not really a plant person, but you really want to participate in this project, adding those other organisms can let you add that insect interest into your site observations, because what it'll do, so the 3 butterfly species I have is the monarch, one of the swallowtails, and I believe a Gulf fritillary. So those are the 3 butterfly species I track in my site for all 7 of my sites. And so when I spot one, it's captured and recorded, and that data is preserved for the future. It's not directly part of what we're doing for time to restore right now, because time to restore is focused on flower timing and seed production or fruit production phenomena for this part of the project. But at some point in the future, it could very much be very important data for some researcher. Keep in mind that Nature's Notebook existed long before Time to Restore was created, and it will be around long after Time to Restore is completed as a project. So think of Nature's Notebook as very similar to iNaturalist, and that there are researchers, potential researchers over a long period of time that could be accessing your historical data. And that's why you might want to add the complexity to your site. Okay. In terms of, so once you've got your plants selected, you've added them to your site, the next issue that comes up is how often do I need to go out there and take a look at my plants? Well, that's when the issue of monitoring frequency comes up. We ask that you visit and collect data at least, or make your observations at least once a week. During peak flowering or peak fruiting season, you want to try to do it a couple of 2 to 3 times a week. That's really helpful for us. And I insert this little graphic right here that shows you if you're collecting data on a more regular basis under this project, it really helps us hone in on when that plant started to produce leaves, when that plant actually set flowers, when those first fruits started popping up. when those fruits matured. And the only way we get that really finite data is if you're out there observing that plant, you know, every other day, particularly during those peak bloom times. Now, the interesting thing about this, and I'll share this with you, is the project is not meant to be overly taxing. So, you know, many people know that generally with flowering plants, there will be this peak time, and then it will kind of dwindle, and you'll go through some fallow periods throughout the year. And that's fine. During the fallow periods, you might not collect data, but every other week or so. You know, you do want to kind of keep the project alive because there may be some research project in the future that could benefit from that data that you're collecting on your plants. Um, but the peak part for time to restore in this project is really what's happening when the initial flowering occurs and when it becomes peak, and then what's happening when initial seed production starts and when mature seed is set on your plant. Those are the two really critical variables we're trying to understand for this particular project. But as you collect data for your site, you can start to think as a community scientist all the other ways that you might collect data to help science and us better understand climate change well into the future. Okay. And that's what this graphic really is intended to do. Remember, almost all of the initial questions in Nature's Notebook are going to be yes/no questions. It will ask you, do you see initial growth on your plant, the one you identified as the one you observed? And it's yes or no. And if that's all you can answer, that's incredibly important for us. But as you get better and better at observing your plant, you will also notice in Nature's Notebook, the questions will let you go to deeper and deeper levels of detail. It will say, so you can answer the yes, no initial growth question, but it also could then say, if you see initial growth, how much initial growth do you see? And then you can go in and assess that as well. The beauty of Nature's Notebook and this project is it's meant to let you go as far as you feel comfortable in the data collection process. The other thing that's really exciting about it is that you will get better and better, and we will provide you with resources to help you get better and better in this effort. Because you as a citizen scientist and as a data collection expert will become a huge part of what happens to this data and how it serves as we move into the future. Okay, so the initial time commitment is, you know, I highly recommend you start small, pick just 2-3 species from the list, that 29 species of plants. You know, some people pick a flower, a bush, and a tree. I think there's only one tree on our list. I think the tree is the Eastern redbud, but there's a couple of flowers to choose from. Pick 3 max when you set up your site. And then as you get more comfortable, if you want to add more diversity, you can either add other organisms or add other plants. The app will let you do that. And the project is very forgiving in terms of if you select a plant and then you change your mind, it will let you remove one and add another. Remember, this is meant to work within your personal time commitments and restraints. And any data you can collect will be helpful and beneficial. Okay. Each observation, as you might gather, if you're only answering the yes or no questions, can be extremely fast. You can do yes, no fairly easily. If you decide to go deeper, obviously it will take a little bit more time. But like I said before, we're trying to capture that start, peak, and end of both flowering and seeding as part of time to restore. That's what we're trying to understand most from native plants. So anything that you can do to collect those kind of data with the plants you observe is really important as part of this project. I'll throw this up there. This is a graphic that shows you that each of the native plants that are on our list have very different flowering times. And I put this graphic up so that you can see, you know, if you're a teacher and you're a master naturalist and you want to do this project, you probably want to stay away. I mean, and you travel for instance, if you take the summers off and you travel during the summer, you probably want to stay away from Eastern purple coneflower, right? Because it blooms most during the summer months when you will be away and not be able to observe data. So in that instance, you might want to try to select a different species that's going to be in bloom and in your wildscape and much more easy to do while you're at home and in your teaching career. Just an example, probably not the best example, but it gives you an idea. So select your plants based on your annual, availability schedule. If you take the summers off or you're a snowbird and you will not be there during a certain part of the year when you know the plant will be heavily in bloom or heavily in seed, you select your plants to allow for you to do both, because we want this to work for you just like we want good data for the project. Okay. Once you've kind of got the basics set up, you've got a bit of understanding kind of what happens when. You got your site set up, you've got your plants identified. The next thing that happens is you will go through what's called phenophasing. And that's when you start to really understand what happens to your plant as the season progresses, right? This is the pheno part of this is the phenological part. That part is the seasonal change of your plant. Okay. So, think of it in a very simplified form of egg, chick, chicken, right? And then its process starts over again, but it's that natural progression that you would recognize. Well, every plant on that list goes through a phenophasing cycle. Okay. And this is Turk's cap. We all, as Texas Master Naturalists, recognize this plant species because most of us have used it in our yard or in a local wildscape. These photos, and you can see the letters down in the corner, show you kind of how the plant moves through the process. And I've created these to have them be teaching tools. But I'll walk you through one so you can see how it kind of works. So if we were trying to phenophase identify these plants, we would probably start out with F, right? Down in the very bottom right, because it's a bud. There's a flower bud just forming, and then a bud that's just starting to emerge. So that's probably, of this collection of 6 photos, the one that's probably the first in a phenophase stage. Okay. From F, we would probably, in this example, move to B, right? Because you've still got your buds and you've got flowers that are just starting to emerge, and you have a couple of flowers that are actually fully formed for this particular species. Okay. From B, you would probably then move to C, which is now you see that the buds are largely gone. And now you have either fully emerged flowers or very close to it with the buds that are around in terms of early flowers. Okay. From C, you would then move probably to E here in this example, because that's the initial fruit form for this species, right? So you would start to see that as the natural process for this species occurs and emerges over time. From E, you would then go to D, which is you've still got open flowers, but you now have fully ripe fruit, right? For Turk's cap, that red fruit is a ripe fruit. And then once from D, you would go probably to A, which is the final in this series, which shows you have both ripe fruit, pristine ripe fruit, and then fruit that's waning, right? There's fruit that's actually on the downside of its fully form. But that shows you a little bit with Turk's cap how a phenophasing would be progress. And it also gives you an indication of what you would be seeing when you were collecting data for your particular plant. And that's the whole point of this project, is for you to be able to recognize and understand what's happening with your particular plant that you're observing. I'll give you a heads up here in a couple of more slides. I'm going to bring up a QR code on the screen that you may want to take a picture of. If you do take a picture of it, it will take you to a place where you can give me your name and email address. And if you do that, I will send you a 100-page botany primer that will help you learn how to recognize when these phenophasing stages are occurring for any number of different plant species. And I'll be happy to do that for free. But be prepared. There's going to be a slide that's going to be coming, and you can take a picture of it And if you'll go in and give me your name and email address, I'll be happy to send you a PDF copy of what we call the Botany Primer, which will help you learn a lot more about plants and how to understand this phenophasing phenomenon, okay? Here's another example, just real quickly, y'all. I'm getting towards the end of the presentation. Here's another one. This is buttonbush, which many Texans know as a plant species that grows in relatively wet areas. But on this particular phenophasing diagram, you would start probably with B, which just shows flower buds, right? Everybody recognizes those as the buds of the flower or buttonbush. From B, you would probably go to C, where you still have a lot of flower buds, but you now have a fully open flower, okay? From C, you would go to F, where you have a preponderance of open flowers, but you still have a few buds there. So that's that natural progression. From C, you would go to F, or I mean, actually from F, you would go to D. D is where the flowers are all largely open, but many of them are starting to wane. Okay, so that we know this process has naturally started to, this is probably very late in the year, probably late September, early October, where these flowers have started to transition. From D, you would probably go to A, where you now have very initial ripening fruit. Many of you may not know that buttonbush starts out with red fruit, and then they mature to a darker form, which is shown in this photo series as it is in E. So E would be the last photo in this photo phenophasing stages illustration, okay? So it would go B, C, F, D, E, D, A, E on this one, okay? And the last example here, this is another one that's very interesting. I always put this example in because it's the state tree from my home state in Oklahoma. And it's also a very interesting one from a phenophasing standpoint. It's one of our priority species for Texas. We'd probably here start with D, right? That's an initial bud. This is the flower bud, because for many of you that are familiar with eastern redbud, it actually produces a flower before it produces any leaves, which is somewhat unique in our group of 29 species, because many of them produce leaves well before they do flowers. But this one, the flowers come first. So that's what D represents. The flowers are just budding. From D, you would go to C, where the buds are there. They've not yet opened, but they're there. And you can just start to see a little hint of the leaves that are going to follow, right? And then many of y'all, if any of y'all are butterfly enthusiasts like I am, you probably recognize that species in that C photo is actually Henry's elfin, which the host plant for that particular species of butterfly is actually the eastern redbud. And it lays its eggs in the buds of the flowers of the eastern redbud. So it's got an interesting natural life cycle in and of itself, in that its host plant as a butterfly is actually the eastern redbud tree. Okay, I digress. But D, you would go to C, then you would go to E, where you see the buds and then opening flowers. So, right, so you're seeing those buds that were in C now become open, and there's more of them that are open than are closed. So that would be the next phenophasing stage for this particular species. From E, you would go to A, where you see a preponderance of open blooms, and you're also starting to see the very first stages of leaves, right? So on this plant species, the leaves come after the flowers. And then from A, you would go to B, which is initial fruit, right? It's the baby fruit, if you will, the first fruit, which on eastern redbuds is actually green, but you can see the seeds forming in each of those pods. And then finally, in this photo series, you would go to F, which is the mature fruit. After they have dried, they can now be harvested and planted. So that gives you a taste of kind of how phenophasing works. And phenophasing is at the essence of this project in terms of kind of what you're understanding about the plants you have selected to observe. Okay, so that will give you a flavor for that. Like I said, we've got a botany primer that I'd be happy to send to you if you have an interest in participating in the project, which will help you learn about how to recognize when a plant is going through a different phenophasing cycle. And then we also have a lot of online training that you can go through to get better and better at this as you start to develop your skills as a phenologist. in terms of understanding all of the natural phenomenon that occurs in our natural environment throughout the year. Okay. I mentioned that most of the questions in Nature's Notebook are going to be yes/no questions. But once you get good at the yes/no questions, we then get into phenophasing in terms of intensity. So it will say, do you see flowers? You will say yes. You will enter Y to say yes. And then the very next question will be, how many flowers do you see? And you can input that information too if you feel comfortable with it. Keep in mind that you don't have to go any further than what you feel comfortable doing. And the beauty of it is all of the data, any of the data you input is critically important and valuable for this effort. So as you get better, you can go deeper into the data collection effort for your plants in your site, and it will continue to help us get better and better in terms of collecting data over a longer period of time and understand these native plant species even more. Okay, so this one deals with flowers. This example deals with fruits. It'll say, do you see fruits? You will answer yes. And then it'll say, how many fruits do you see? And you can then select that number of fruit. And then it will say, if you see fruits, how many of those fruits are ripe? And in this instance, you would say none of them are ripe because they're all just new. Okay, this milkweed species, actually, they turn brown after they've ripened. And so that's how you would know that these are not ripe. But at some point in the future, you'll be able to answer, yes, I see ripe fruit, and you'll enter the number of how many ripe fruit you see. But that's how this intensity works, and it helps you as a data scientist get better as you observe that plant over longer periods of time. The other thing is that if you designated a patch of plants, it's real easy to look at plants and say, okay, I see 4 fruit on the head of that one plant. But there's also this issue of intensity if you have designated a patch of plants. This illustration actually shows you what a patch of bergamot, this is a Monarda species. Bergamot's I think this is just wild bergamot, which is not one that we know here really well, but there are a number of Monarda species that we do know, and particularly in the Gulf Coast, see quite a bit. But this would be an example of a patch of plants that someone has identified to collect data on. And you can very easily see that if this thing was setting seed, it might become very overwhelming to try to determine, the question asks, how do you see flowers? And you'd say, yes. The next question, if you were getting good at this, it would say, how many flowers? Well, the way we do that is we do estimating. So you could say, okay, this is a circle. That circle has 10 heads in it. And I think I could probably estimate that there's 10 of these circles over my patch of plants. You see how we did that? So it's a technique that we use to estimate the amount or intensity of plant flowers on this particular plant species. And so you will learn over time how to get better and better at estimating if you've identified this as a patch of plants that you want to observe in your site under Nature's Notebook, okay? I also throw this one in because I mentioned Monarda. Many of y'all know, there's a number of Monarda, particularly in North Texas, that when you harvest seed with Monarda, it's not as very straightforward. Like, for instance, if you do basket flower, it's pretty easy to harvest seed and you know exactly how many seeds you get out of a head of a basket flower. But there are others like these this Monarda species, Fistulosa is what this species is, they do not produce seed, they produce what's called nutlets. And all of those are seeds. And so you can very quickly see that estimating the number of seed could be impossible, right? This is impossible to estimate. So this would not be a question that you would probably want to answer, only because it will give you a headache to do so. And that's okay. If you don't feel comfortable answering it, just skip it. That will be perfectly fine, and it doesn't hurt all of the data you collected up to that point. Remember, Nature's Notebook and your efforts under this project are extremely forgiving, and we just want you to do with what you feel is comfortable and progress as comfortable as you feel, okay? I also mentioned, so that's the nuts and bolts of the actual project. That is it on it. It's very simple, very straightforward. Um, Once you create your profile in Nature's Notebook, if you decide to do this, once you create your profile in Nature's Notebook, you will then get access, and it's all free, training on how to get better as a data scientist, as a phenology data collector. And those training resources are organized as modules, and they're all self-paced. So if you want to go in and you say, I want to learn more about how to recognize phenophasing stages, there's a module for that. If you want to go in and learn about intensity, phenophasing intensity, there's a module for that. And you can go through and learn those at your own pace, online, in the leisure and seclusion of your own home, and get better as a data scientist in this effort. We want you to get good at this because that means the data will be getting better. So we will, over time, provide any number of resources to help you get better at learning what your plants are doing, how they're changing, and how you can record that data. Okay. We'll also, if you provide your name and email address and indicate that you want to be part of the project and you want to receive more information, we also will be sending out on a regular basis, usually once a month, once every other month, info sheets on the particular plant species that are important in Texas. So over time, we were able to capture photos and record data about individual species on that the list of 29. And then we are developing these info sheets to be able to share with the population that are collecting the data. And so you'll get better because you'll be learning more about the plants that you are observing, and particularly those that are growing very close to you in your own yard or in a nature wildscape that you maintain. Okay. Almost to the last of this, y'all. The slide that's up there now is kind of what's next. So if you were to decide this is the project for me and what I need to do, we'd love to have you. We've got master naturalists all over the state that have now gotten this project approved by their chapters. And so the beauty of this project is you can actually get volunteer service time once the project has been approved by your volunteer services coordinator. You can get volunteer time for collecting data in your flower bed under this project, because it is a data collection effort that's meant for us to better understand the natural environment and native plants in particular. Okay. But what's next is you would then select a site. I mentioned we're going to do a training on Thursday night. We can walk you through that process. And I'm about to show you, get ready with your phones. I'm going to show you a QR code. You can take a picture of it to get registered for that training this Thursday night so that you can become set up and ready to collect data for this effort. Okay. But once you've selected your site, you know, do that in your head first, because that will kind of help you frame up how you move forward here. Once you've kind of in your head selected your site, know kind of what you want to do. If that's your front flower bed or a naturescape that you volunteer or work at, go ahead and then download the Nature's Notebook app from your app store, whichever, Android or iPhone, whichever you use. Go ahead and select your plants in your mind next. And then once your app is downloaded, you'll go in and create your Nature's Notebook profile. And we're going to help you do that on Thursday as well. But it's also a fairly straightforward process. If you've set up an iNaturalist account, you'll find the Nature's Notebook profile very easy. It's just identifying that it's yours. You give it a password. You identify kind of what state you're in and kind of a little bit about how you're interested in Nature's Notebook and what you hope to learn from it. You will then go in and set up your first, what we call personal site. This is that site that you mentally identified at the top. You will now identify it in the app as your personal site, usually with an address. So if it's your yard, you'll put in your address. Keep in mind, only you can see the address. The address doesn't go anywhere. All of our data is aggregated, so there is no individual connection to your address. The only time that we know a individual site and where it's at is if it's shared, and you have to do that. Most wildscapes that are at public facilities, like at a botanic garden or at the Herd Museum, If they were to go in and set up a site for them that they wanted multiple volunteers to be able to collect data at, we call that a local phenology program, and those sites are shared. So you would have a group of people that would be collecting data there, and those are the only sites that you can see among the people that are collecting data. So you have to join the local phenology program, and then you can collect data at that site. But most of these are individual personal sites that you set up, you manage, you specify, and then you maintain on an ongoing basis. Once you've got your profile set up, you've defined your site, you then specify your plants, right? That's which plant you're going to observe, which patch you're going to observe, make it only 2 or 3 species, and then you're good to go. You now have a profile, you have a site specified, and you've added your plants that you're going to observe over the long haul as part of your data collection effort. Once you've done that, you will then do like you did in iNaturalist. You will go through Nature's Notebook, you will search for the Time to Restore project, and you will join it, okay? And when you join it, it will automatically make all of the data you collect part of the Time to Restore project. Anytime you are collecting data on the 29 species of plants, it will be added to the project, okay, automatically. The beauty of using the app is you don't have to tell it when you do it. You don't have to go back at the same time. It literally will take care of everything. It's just answering your yes/no questions about the plant you're observing, and then you move on through your day. It's a really easy process. Once you have that set up, you're now ready to begin collecting data. The beauty of this project also is you don't have to collect data on the same day. If, for instance, one day you're able to do your observations on Monday, but the next week you're only able to do it on Sunday, that's okay. Remember, more times you visit your plant, the better the data gets for us, especially during peak bloom time and peak seed time. So we wouldn't be unhappy if you went out there every day during peak flowering time and recorded what you were seeing on that plant, because it's going to give us very detailed and very important data. With that, you're collecting data, and then the only other thing you have to do is begin to promote the project, help spread the word about what we're doing here, because this is your opportunity as a community science volunteer to directly help pollinator efforts, restoration efforts across the state, across 4 states in the US, and really help us understand what's happening in the face of climate change with native plants and the pollinators that they rely on and rely on them. So it's a really important project, and I hope you'll consider it. And I thank you for everything that y'all have considered tonight. And hopefully it wasn't too much too quick. I mentioned this is the QR code for the training on Thursday. If you want to take a picture of that so that you can register. If for some reason you don't get that or you have problems, you can always email me and I'll help you get registered for the Thursday night session. It will start at 6:30 on February the 27th. It will also have master naturalists from all over the state. In fact, I checked, I think we're over 100 that are already registered. The number that can register are unlimited. So please get on that. We'll be walking through volunteers through the process in a very slow manner via a computer desktop. So you'll be able to see exactly what we're doing to set up our site. In fact, if you have the ability, you can actually set up your own computer and walk through the process, setting up your own site alongside us. And that would be a great way to do that. Okay. So that's the QR code for the training on Thursday evening for setting up your own site. I'm also going to put this up, which will give you a QR code for that free botany primer. So if you have an interest in that free botany primer that I mentioned earlier, so that you can learn more about phenology and phenological observations, be sure and take a picture of this QR code and go to it and give me your name and email address. And then probably by the end of the week, I will send you the PDF copy of that botany primer so that you have it as a resource that you can learn from and get better as a phenological data scientist. In this effort and many others that you will hopefully participate in as you become experts with Nature's Notebook and the tools that we use for this particular project and many others. With that, I'll stop. Why don't I do this? Why don't I go back and leave that slide up? And Vicki, Callie, I'm happy to answer any questions that anybody may have.
Thank you for that great presentation. We have just a couple of people that put questions in chat. The first
Okay.
one was just a clarification, I think, that if you are observing a whole patch of plants, do you record the first change, like the first sign of budding in any of the plants in your patch?
Correct. That is correct. Because as you get better as a data scientist, you will be able to then go into intensity, which will say, if you see that flower, the next question under intensity would be, how many flowers do you see? So if you're not comfortable with the intensity side, it'll just be a yes, no. Yes, this plant is in flower, based on just that one observation.
Okay, and then we have a question about if data that has previously been collected in INAT, would that be of use to your project?
It is, and in fact, actually, we're already harvesting it. So just so you know, and actually, I don't know, since y'all are in North Texas, you probably are aware of BRIT, which is the Botanical Research Institute of Texas, which is based in Fort Worth. We actually have paid staff that are going through all of the herbarium collection to note when those plants, when they, we know specifically when they were collected in the field. We're now going through and identifying which of them were in bloom and which of them were in seed by the specimen. So we are using all of the various data sources to feed this model so that the data can then be used for research studies across the country, particularly as this data was intended. So the quick answer is yes. There are some very close examples to your home in terms of how we're using other resources. The beauty of the INAT data is you don't have to do anything. We're going through that process automatically. You probably noticed a few weeks ago, I think probably in early January, INET did a training to help people start to collect phenological data on observations they were making. It was in large part to this effort. We're all understanding that climate change is real and we need to be a much more educated about what it means. And so this project, you're seeing other types of users, other types of tools trying to be more sensitive about how we're collecting data so that it's available to the research community so they can help us be ready to tackle the challenges that will come.
Great. I've got one more question. Do you have a preferred vendor to order native Texas seeds that are on the 29 selections on the priority plant species list?
We do not. Obviously, that's something that you really probably want to work through local providers. We do heavily work very closely with NPSOT. So if you want to use their recommended, we think those would be great sources. NPSOT has what's called a NICE program, which is a program that they vet vendors through to make sure that they're using plant species that are truly native to the various parts of Texas. So that might be a great resource for you to try. So that might be something to do. One of the things that has come up, and I'll go ahead and share this with you, be sure that you do have that plant species. For instance, some of these can be a little difficult, like the goldenrods. We've already had an issue of somebody thought they had one of the goldenrods, come to find out they had a different one. You might, as you start out, pick plant species that you really can't confuse with any other species. Just as you get going, you start to get familiar, and then you can go into some of the plant species that are a little bit more complex, like the goldenrods. Goldenrods are great pollinator plants, but they can be very difficult to identify, particularly if you have them growing in a microclimate, because they tend to do different things when they're growing in those microclimates and might make you think it's a different species. So just be careful about that. Most of the other plant species are fairly straightforward and they were selected because of that. Okay.
All right, and then we have one request to go back to the QR code for the Elm Fork presentation.
Okay, let me go back. How's that? Yeah, and like I said, y'all, if I'm noticing in the chat that there may be some people that are having difficulty with the QR codes. Jot down my email address, send me an email address, and I'll be happy to get you the connection. We use the QR codes because it's easy for people to put their phone up to the screen and go to that site right then. But if you have, for some reason, difficulty either getting your name and email address to me so that I can send you the botany primer, or to get registered for the Thursday night training, please just send me an email and I'd be happy to connect you with those. Also, with the training for Thursday night, if you have a conflict and you can't make that training, be sure and go ahead and register for it, because everybody who registers for it will get a link to watch the recorded version of it. And you can watch that at your leisure. But if you don't register, I won't know that you wanted it. And so that could be a problem. Okay.
All right, let's see. I have one question. What is the best source to confirm the plant species you don't know?
The best source is to reach out to your local NPSOT chapter, because actually, let me back up. Every Master Naturalist chapter that I have been involved with in the last 20 years usually has one or two people that are known plant people, and they are very good at being able to identify plants. But you can, if you don't have one of those in your chapter, you can also reach out to your local NPSOT chapter. Most of our Master Naturalist chapters are overlapped by a NPSOT chapter, and they would be more than happy to help you identify any one of those 29 species. And like I said, try to go for a species that you really can easily identify. Go for buttonbush. There is no competing plant for that if you can grow a buttonbush. If you can't, pick something that mistflower. There are two mistflowers. Here on the Gulf Coast, blue mistflower does much better. In North Texas, it's usually Greg's mistflower. Both of those are on our list. Go with that one, and it'll really help you out in terms of not having to worry about which one you have. But also your NPSOT chapter can be really good. Also, y'all are particularly benefited by the fact that Carol Clark is in your area. And I hesitate to commit her to this, but I bet she would be a real good resource as a plant person, particularly as it relates to species that are important to pollinators. So she probably knows all of 29 of these species very well. And I bet she would help, or any number of other individuals that are also plant people might help as well.
Okay, I did not see any further questions. I want to thank you. That was a fantastic presentation. I'm sure everyone enjoyed it, and we appreciate you sharing that information with us.
Well, thank you so much. I apologize again for going a little long. I was trying to get it into an hour. Sometimes that's very hard. Like I said, this was a 3-hour workshop that we've boiled down. If anybody, so this presentation in its workshop form is still scheduled to be done in mid-March in Brenham. So if anybody is ever in Central Texas, it'll be a 3-hour workshop that will be done in Brenham, which allows us to go into a lot more detail on a number of these things. So if you have that connection, it's free. The local Master Naturalist chapter is hosting that on a Saturday in March. You're welcome to join. And if there's anything that the Blackland Prairie chapter would like to go into in more detail, like Elmfort did on the training that we're going to do on Thursday, just reach out to me. I'm happy to set up and see if we can work through any educational challenges you might have in terms of being able to participate in the project. I hope that Blackland Prairie will come at this with enthusiasm and vigor and join us, like many of the other chapters are around the state. It's an important project and it makes a big difference. So thank you so much for your time. I apologize for going so fast, but I'm a resource. Please send me an email, dgwin@ymail.com. And yes, that's a Y. And I'll be happy to answer any questions or assist you in any way that I can. Thank you again.
Thank you, Dave.
You bet.